name is Shreya Bansal, and today we are going to talk about another class of problems which would be binary search tree advanced problem solving. Okay, so we have one problem statement here that we need to solve. Let's take a look. So the question says that you have been given a binary search tree, okay, and it's noted by the root node as A, and here we are also given a number B. And now you need to find or look for a pair of node in A whose sum is equal to B. Okay, so you need to find two nodes whose sum up or whose sum value would be equal to B, which is also given to you. Alright, now here if that exists, if there are two nodes that actually sum up to B, then you can return true in your answer, or else you can return false. Now remember, over here you do not need to find those two nodes, you just need to know whether such kind of two nodes exist or they don't. Alright, now in the input format you will be given the node of the tree, okay, the root node of the tree, and in the second argument you will be given the integer or the target value B, and you need to just return true or false in the output. Let's take an example. So here we have 10, 9 and 20. Okay, so we have 10 as the root node, 9 and 20. And now let's say the target value B is 19. So you need to check whether there are two nodes which actually sum up to 19, and we can very clearly see over here that it is true. So the answer is true. Now if I give you the same tree but with the value, let's say 35, what you will see is there are no two nodes in the tree which actually sum up to 35. So in this case your answer would be false, that no, there are no two nodes which actually sum up to 35. Okay, so you have to do this in such a way that you find the correct answer. Okay, so I hope the problem statement is clear and you've seen how the problem or what the problem looks like. So now what we'll do is we'll figure out a way to solve this question. I would recommend to kind of relate this question to the other question that you must have already done before, which was, you know, in an array you need to find two sum which basically sums up to the target, correct? So if I need to find B as the target value, there must be two nodes X and Y which are basically equal to B. Now think of it this way. When you are iterating over the tree, right, or traversing the tree, which could be any kind of traversal, in order, post order, pre-order, you are going to each and every node, correct? So this is one of the X node that you already know, right? And this is the value also that is already given to you in the question. So hence you just need to find out this node, correct? So my, let's say, summation value is 35. I'm currently at the node 10. So if somehow in an optimized way I could know if 35 minus 10, 25 is existing in this tree or not, then I'm done, right? My answer is done and I have found my solution. Okay, so what we'll do is at each and every level we will try to store the node's value at some position, right, and then see how this overall idea works. Let's take an example. So we have 5, let's say we have 3, we have 6, we have 2, we have 4 and we have 7, and let's say the value of B is 9. So what will happen over here is you are at 5, okay, and you're also maintaining a set which will have the values which you have iterated. Now you have 5, you need the sum to be 9. So if 4 exists in the tree, that means you're done. So you will check the set. Currently we have not traversed any node which is 4, so we don't have the answer so far. So just add 5 to the set and move forward. Then maybe if it's I can say a pre-order kind of a scenario, so you go on the left subtree, you see 3. Now you have 3, you need the sum to be 9. So if somehow 9 minus 3, 6 exists in the tree, you have your answer. But currently we have not seen it, so we'll just store it. Next we go to 2. Now 2 is what we have, which is the value of X. B is the sum we need. So basically if 7 exists in the tree, I am done. But currently we have not seen it because it doesn't exist in the set. So you go back and you come over here. Now you have the node value 4, right? If somehow you can get 5, your answer is done, and you will check the set. Have I actually traversed any node which is equal to 5? Yes, I do. So if the set contains this value, you are immediately done over here. You just return a true in the answer. Okay, so that is what you have to do over here. You need to check for a node, right, and see if it is present or not, and then figure out your answer. Let me give you another one. Or since it's a binary search tree, let's take let's say the target B is 34. So here I start with this node and this is the set. So the value is 20. If I can find 14, I am done. But I don't have 14 so far, so I need to move forward. I have 15, I need 34 over here. Correct? So if somehow I can get 19, I am done. But I don't see it, so I'll just add it to the set and move forward. I have 16. If somehow I can get 18, my job is done. But I don't have it so far, so I'll add it. Now I'll go back, I'll go over here, and this is 18. Now I have 18. If somehow I have 16, I'm done. In the set, I can actually see that there is a node 16 existing. That means I'm done over here, and I will return true for my answer. So no need to even check further as well, right? The moment you see you find a match, you can simply go ahead and move forward with this. Alright, so I hope the logic is clear. It is very, very similar to the two sum problem in an array. It's just that here you have to implement it in a tree. There you simply could iterate an array using a pointer, right, and using a simple for loop. Here you have basic tree traversal techniques that you can apply. Remember, there is no rule to which traversal technique you pick up. You can use in order, pre-order, post-order, anything you like, and everything will work. Okay? Alright then, let's quickly take a look at the implementation also and see if we are correct or not. So, we'll write a function which will be something like find target, where we are passing the root and we are passing the node B. We'll create a set, okay, and then we will recursively call the find function, passing the set, or let's say passing the root, passing the set, and passing the value B. So this function find, it will have the root, it will have the set, and it will have the B. Okay. Now if root is null, remember, since it's a tree order traversal, we'll again apply recursion only to do this. So this is the base case. If the root is not existing at all, that means nothing to be found, so return false. If you're currently at the node root dot value, so basically you need to check in the set if it has root dot value, kb minus root dot value. If it does exist, you simply return true. Correct? Otherwise, you keep looking after you add the node. You keep looking in the left and the right subtree. So you see if it is returning true from the left subtree, or it maybe returns true in the right subtree. Any of them can return true, and that would be good. Okay, let's see. So here we also need the root node. Okay, and here we'll also create a new node. We'll do n dot left. Let's do this as 10, the tree that we know. N dot left is 9 and n dot right is a new node with the value 9. Here we have a new node with the value 20. And now we'll simply call this find target function, where the root is n and the value is 19 for a sum. And let's see if this works or not. So we have let n, we have n dot left, and we have n dot right is equal to the new node. Okay, so what happened over here was we were accessing the root dot value with root dot val, and here we mentioned it as data. So if we just simply change this, I think this should work. Yeah, so you can see this works now. Alright, we have 10, we have 9, and we are trying to find the sum, so it returns true. Let's keep the value 21. Then you can see it gives me false. Alright, so this is the way we're trying to print the value. You can directly see this way also now. So you can see false. Okay, again for 19, you can see this works and give this as true. Okay, so very simple code, very simple idea. You can see how a simple sum question which is used for array can be applied on trees as well, and you can very well solve it easily. Okay, so I hope I was helpful in helping you solve this particular question, and I will see you in the next one. Bye.